Okay, this is my audience for my speech class. Is it all good? It's good, okay. My name is Jonathan Kiser, and this is an informative speech for speech 1321. Today is June 24th, 2023. Well, that does it. Those were the words of Louis Slotin, a Manhattan scientist, after a demonstration went wrong. In a freak accident, the nuclear core slipped and opened up and exposed itself to many of his co-workers. But how did he know that was it, that it was over? Today, we will be covering radioactivity so that you may have a better understanding of what radiation is, the different types of radiation, and where to find it, and how radiation affects us. I can see that you're already shining. It may be from enthusiasm or radiation, but enthusiasm is a psychological behavior. What is the physical behavior of radiation? Radiation is the byproduct of an unstable molecule or an element decaying. And an element decays because the amount of protons and neutrons further down on the periodic table, it has more mass, so it has more protons and neutrons, making it heavier and more unstable because the proton forces between it push away, repel each other, which gives it enough energy to decay. Any element that decays will produce radiation, but not all elements decay at the same speed. The rate at which an element decays is called the half-life, and the half-life is how long it takes for an element to decay to half of its original mass. The shorter the half-life is, the more radiation it produces. But not all radiation produced from decay is the same. There are three main different types of radiation: alpha decay, beta decay, and gamma emission. Alpha decay is the eroding away of a helium ion, and the helium ion is the same as a helium atom, except it's stripped of electrons. Alpha decay occurs in the heavier molecules with more neutrons and protons more further down on the scale. And where you can find alpha decay is up above you in your smoke detectors. Smoke detectors use alpha particles to ionize the air inside of it and carries a current through that air. And when smoke enters the detector, it will reduce the current just a bit and the alarm will be set off. And Wikipedia says that most of the helium currently in the atmosphere is caused by radiation from alpha decay. Beta decay is the emission of an electron from the atom. It is what happens when a neutron goes into a proton and it releases an electron. There are other types of beta decay, such as positron emission and electron capture, which positron emission produces a positron and electron capture absorbs an electron. And where you can find beta decay is in carbon dating, which is used to date how old something is by taking how much of the carbon has decayed and dividing it by how much has yet to decay. Gamma emission is an electromagnetic radiation which is on the same scale as radio waves, microwaves, color, UV rays, but gamma rays are the most powerful out of all of them, having the shortest wavelength, and they occur when a positron and an electron clash into each other, and it annihilates them both and forms a gamma ray. Gamma rays can be found alongside beta radiation in chemotherapy, and gamma rays are used to treat fruits, to get rid of all the microorganisms. And Chernobyl, the radiation output from Chernobyl is gamma radiation. This is all good to know, but how does radiation affect us? All radiation affects our body in the same way because it's all ionizing radiation. And ionizing radiation will go into your body, destroy cells, break apart the cells, and indirectly it also ionizes the water molecules in your cells and turns it into hydroxyl radical. It's a difficult word. Hydroxyl radical. And that can react with the DNA, enzymes, and proteins in your body, disrupting the psychological products, how it normally functions. And radiation also is more noticeable in the cells that reproduce quickly, like hair follicles, stomach lining, bone marrow, and embryos. And that's why after getting an x-ray or so, you may lose hair, have a stomach ache, or bone ache from what OpenStack says. And there's also one other way that you can experience radiation, and radiation is pretty common in your daily life. Bananas produce radiation from potassium, the sun produces radiation, your own body produces radiation, and in your living room right now you are breathing in radon gas, which leaks up through the ground from decaying uranium. And since it's denser than air, it rests on the bottom floor. And radon gas is more dense than air, and it is the second leading cause of lung cancer behind smoking. But the amount in the air is quite insignificant. And a Roentgen equivalent for man, that is the unit they use for radiation to tell how radioactive something is. And how it's found is the radiation you're exposed to multiplied by the damage it does to your body. And 400 looks like a short amount, but a banana produces only 0.001 rem from what Wikipedia says. And 400 is needed in a short period in order for the possibility of death, and 2,000 is like you're gonna die in a few weeks. In Britannica, story of the scientist at the very beginning, he was exposed to 2,100 rem instantaneously, and he vomited immediately and died an agonizing death 9 days later. So I hope that this speech was informative and you learned a little bit more about radiation. Let's review. Radiation comes from unstable elements that decay into a more steadier form. The three main types of radiation are alpha decay, beta decay, and gamma emissions. And we are exposed to radiation daily. That radiation tears apart your body, destroys your cells, but unless you're a nuclear scientist, you most likely won't be exposed to radiation, commonly, at least large amounts. And, well, that does it. Just as Louis Slotin accepted his fate, we must accept that the speech is now over.